audio this morning. Okay, great. So if people could get the light in the back, that's great. So this morning we're going to be delving into the first of two big topics that are going to occupy us for the next, I'll be with you just a sec, for the next week or so, and that's going to be non-strictness, laziness, and streams on the one hand, and error handling in a robust fashion that will be suitable for pipeline contexts. Yeah, Warren.
Sorry to jump in.
Yeah.
But, in the syllabus it says that the problem set number 1 is due February the 5th.
Yeah, so I'm going to have to push that back. It has to do with the scheduling of the lectures and what I've been able to cover thus far. I'll probably be releasing that later this week, but I'm going to have to push the date back by about a week for the due date. So it won't actually be due the 5th, but the week beyond that. So thanks for asking. Anything else I can deal with right now? Okay. So as I noted, the next week or so, and it's going to be probably 2 lectures on streams and non-strictness starting today, and then a lecture on functional error handling in a way that's robust and can scale to higher performance. We're going to be hitting on a group of topics. Now, I did ask you to undertake an exercise here where we built on some of the understanding generated by the last session, and I asked you to play around a little bit more with these mechanisms, particularly using a set of higher order functions that we had looked at in class, like map, filter, group by. And I had also asked you to look at use optionally of dictionaries or maps, as they're called in the Scala context, which would be important for delivering on the functionality. And as part of that, I asked you to go and make use of a few basic mechanisms within Scala that would help you. Some of them were simple functions that you can call, such as the split function, which uses regular expressions to split up strings, the getLines function and toArray function, and the 2 lowercase function. And I asked you to try to accomplish 2 basic things. One thing was to count the number of times that a given word appeared in the document which I had given you, and secondly, the number of occurrences of different word lengths, meaning of words of length 1, words of length 2, words of length 3, etc. So I'd like to ask the folks here who struggled with this exercise, how did you go about pursuing this? What mechanisms did you use to explore this within the Scala shell? So if I'm sitting here in Scala, what do I have to do?
Make the text into an object first.
Okay, good. So I want to use these mechanisms here to render the text into a form that can be processed. And I've actually given you the key steps here, which basically allows you to get a bunch of lines. And here I've rendered them into a form of a collection, in this case an array, to allow us to process those one at a time. If we don't do that, getLines actually returns an iterator, which is something that you can iterate over. You can sort of go through one by one, but it's more convenient if we can put them into a collection. So I've suggested that you put them into a collection. So that's step 1. Actually, maybe even step 0 is importing. We have to import something for this, right? What is it, Scala.io or Scala.io._, thanks. So we have to get source loaded up, and then we have to turn this into an array. We have to be in the right folder to access this document.txt. What do we do next? Okay, we have to filter out empty lines. Okay, so that's good. Maybe we'll go through and do this together. Might as well, right?
That after you get individual words, it's a lot easier.
Yes, you can filter out individual words here. So I've actually taken the liberty of doing this, but I think I still need to do the import. Yeah. So here, import scala.io, and we have to import everything from there. And okay, so we're gonna have to map that split over it. This is what this gives us. Okay, and you'll notice that this is a array of the individual lines of the document, and it includes some empty lines here, right? So it's true that one thing we could do right now would be to filter out empty lines. Suppose that I wanted to do that. How would I do that at this point?
Filter where a line doesn't equal blank.
Okay, so we could say this not equal to something like that. Yeah, we could do that, or we could do this dot length greater than 0. Right? That's another way to do it. Yeah, Warren.
Also, not filter or something like that as well.
Uh,
As well.
oh, okay. So filter. Is there a filter not?
Not filter.
Not filter. Oh, okay.
Capital N-O-T.
Cool. Cool. Okay. Filter not. Wow. That's pretty nifty. Okay. Something like that. Yeah. Good. Okay. But what do we have to? So we could filter it out at this point. I'm going to come back to Connor's point. What do we have to do now in order to go to render this into words?
Use the split.
Okay, so we're going to use the split. And I actually had it there earlier. It may still be in my buffer here. Yeah. But what do we have to split up?
The individual elements of the array into more.
Okay, yeah. Can I just do this? Why not? What's the matter with that conceptually?
Also, it should be applied to a string, not a array.
Yeah, so you can apply it to the whole array. It's like, hey, split this array up. By what is this? What is this thing that lies before us?
It's a regular expression.
It's a regular expression. And what is this regular expression? What does this regular expression denote? What strings match this regular expression?
Things which start with a character and have one or more of them.
Okay.
Or non-alphabetic.
Non-alphabetic characters. The plus is basically a shorthand for the thing, and then the thing repeated 0 or more times, like with a star. So it's kind of like a variant of star, which indicates 0 or more, but this indicates 1 or more, right? You can also do it with curly brackets to indicate between 2 or 3 of them, or 5 to 10 of them, or whatever. But this is for 1 or more. Okay, but that's a modifier for what's in this square brackets. The square brackets actually denote possible characters, which would then be repeated 1 or more times. And what's inside that square bracket? What does that denote? That denotes this is alphabetic there, but what's this caret mean? Non-alphabetic character. It's a modifier for kind of inverts the whole remainder of this thing. So this is, this A through Z in lowercase and uppercase means match anything that's a lowercase A through Z or capital A through Z, and this not means match anything that's not one of those. So this is indicating we wanna split it whenever we encounter a sequence of 1 or more non-alphabetic characters. That's where we want to split. Want to split it there, so we'll subdivide it. So we're trying to apply it to the whole array. That doesn't work. So what do we need to do? What do we need to do to make this work? Here we're applying it to the whole array. It's going to be an unhappy camper. We need a map. Good. Because remember, map's job in life is to take a function and apply it to each successive element in turn, producing a collection whose elements consist of that function we gave it applied to the corresponding element of the original collection. So here we're doing map, and without a lot of fuss, we'll just apply it to the thing that's there. Remember, the underbar means.
Maybe specifically as flat map, because you can get all the bars in singular, and besides you can also
Good.
increment to lowercase and then split,
Good.
so that you can have all the words in lowercase.
Okay, yeah, so we could have done lowercase before this. So I like what I'm hearing. So here we've done a map, and what it's
You've still
taken.
got empty lines.
Sorry?
You've still got empty lines.
Yes, we've still got. Well, they're not empty lines; they're empty arrays that are going to yield.
No, look, there's one right there, right beside C. Dillon.
Where is this guy here?
Yep.
This is an empty word, right? It's an empty word, and it's going to be broken up later into what empty lines would have been mapped to. So here we had this guy here, since we applied a map. When we applied the function associated with the map, this split here, that yielded this array. But that's not really what we want. So we want what? I heard it earlier from this gentleman there. And what did I say? What do we?
Single giant array.
We want a single giant array. And how are we going to get it? We're not going to do map. We're going to do flat map. Okay, flat map. Okay, now we've got this, but we still have the counter issue, to which I promised to return earlier, which is we've still got these rogue empty strings in there, which we would have gotten anyway before if we hadn't stripped out those empty lines. If we hadn't stripped these out at all, we just would have more of them, right? They'd be legion. So we want to get rid of them, and we might as well do it. Might as well do this filter not. Okay, this dot length. Oops, equals 0. Here we are. Okay, now we've gotten rid of these zero length things, but again, pursuant to the comments earlier, we still have the issue of lowercasing this. All this is uppercase, and we want to consider something in lowercase and uppercase the same. So if someone happens to write at the beginning of a sentence, A with a capital A, and then if it appears in the sentence A with a lowercase, each case as a separate word, we want to consider them the same. Same thing with university. Might appear in a sentence with a lowercase at the beginning of a sentence, or in a proper noun with a capital U. So we want to canonicalize all those. So where should we put that? Well, we could. Yeah, we could. Sorry, we could put it in flat map, but by doing it in flat map, so we could do it. We could say this to lowercase. Oops. Okay, why is it? It's not a member of the array. Okay. We actually can't. That yields. We could do it before this to lowercase, but we're kind of combining conceptually two different operations at once here. So I'd prefer to put it in another map. And we could do it here, or we could do it at the end. Might as well do it at the end since we've reduced it, right? Map this dot to lowercase.
You could do the same thing inside flat map.
Yes, I had noted we could do it inside flat map right here. But
With
it's
a map. You can do
sorry?
it with a map inside a flat
Yes,
map.
we could do it with a map inside a flat map, but it's a conceptually separate operation. And the style that we're aiming at here is to create a pipeline that consists of separate modular components. And if we nested that, you're right, we could do a map here, but if we nested it in there, now we've got two different pipelines, sort of one associated with inside the flat map and one here. And it is conceptually simpler and more modular to have this a separation of concerns associated with these different stages of processing in a linear sequence rather than having two different sequences. Sometimes you can't avoid it. Sometimes that ends up being desirable. In this case, I would say it's more desirable to have a single flow here. We're going to come back to this point in a big way by the end of the week. Probably it will be Thursday when we start talking about streams. Because in a stream context, what's going to go on is that these successive operations in the pipeline, these successive stages of processing, are going to be undertaken incrementally. So a given item will be successively marched down here and applied without the need to create an entirely new collection along the way. Right now, we're applying this to arrays, and so, you know, if we do this, we could, if we really think about what's going on here, what's going on is that we are doing this. Okay, this is getting an iterator, and then we are going to go get the array here. This is producing yet another collection, right? That's a collection that's produced at that stage, right? It's a full collection. Then we do a flat map. This is creating yet another collection at that stage. So once it reaches this stage, it's got a full collection, and then we could do this, this filter, and then we can do this map. Each of those, at each point along here, it's creating a full collection, and that's going to be in stark difference to what we see with streams, where it's going to be performing these incrementally on each data item on an as-needed basis. Okay, so here we are. We've got this lowercase stuff. What do we do now? How are we? Start gathering. Okay, so suppose let's apply ourselves to the first task, shall we not? Count the number of occurrences of words. How are we going to do that?
Group by.
Okay, so we're going to do group by, and by what are we going to group?
The two string of the string.
Okay, so we're going to group by the
String value.
the string itself.
You can't just type in A though, I tried that. You have to actually give it the two string of the string.
Okay, let's try this. If we group by this, what is it going to say? Missing parameter type, okay? So I'm going to say string, and we'll map it to the string. Okay, what am I looking at now? What's this rate goes to array of rate.
All the rates.
These are all the rates across this entire document. Submitted. There's these occurrences of submitted here. Where did those occur in the document? Well, many places. Look at abstraction. Man after my heart. You can tell he's one of my students. Abstraction. You could just keep me going. Yeah.
Sorry, I wasn't really satisfied with splitting on non-alphabetic characters because this document had really weird punctuation. There were situations where like FIs in fulfillment were replaced with periods, and there were hyphens carried over, like parent would be PAR hyphen ENT. And
Okay.
this way, splitting
Fair
on the
enough.
punctuation would also give you lots of like singular S's on contractions and stuff.
Fair enough. So if this were a more fulsome exercise, I probably would have asked you to try to deal with those things. Although, to be honest, when I produced this document in haste, I did so by simply exporting from PDF document, and it simply yielded some garbage. Yielded this stuff in there that I didn't really intend to put in, but it was there. But you're right. I mean, hyphenation might break a word that conceptually is one word, and really it's more a matter of formatting than it is of content. And so splitting up based on this is perhaps not what you want. Also, there are characters outside of this that are meaningful, right? There's accented characters. You have an accent aigu or an accent grave, and these things aren't going to appear there, and there are those in this document. So, you know, I think if we were looking at a more robust processing of this for important purposes, we would pursue a strategy that's more sensible than this. But for the sake of teaching something about creating these sort of pipelines, it's a useful approximation, I'd say. Okay. Okay. So here we go. We have a what is this thing? What is this thing that sits before us? What are these little arrows?
They're mappings.
They're maps. And so what is this entire thing? It's a dictionary or map, and it maps from a key to a value for that key. And the values here happen to be what? Arrays. Okay. Grouping by is taking these strings and it's grouping them into collections according to some criteria. And the criteria here was we're grouping by the word. And so if the word occurs multiple times, we'll get all the instances of it. So these are all the instances, scattered as they are through the document. Okay. Great. So how are we going to count the number of occurrences of the word? Map values. That's going to map the values part of the array, these things here. And how are we going to what are we going to map them?
Count something. Whatever the array's count is.
Okay, good. So we're going to take the value, which is going to consist of these arrays, and we're going to ask for its size. Right? There we go. Okay. So here we go. There were 2 occurrences of pathogens, 10 occurrences of rates, 30 no less of abstraction. Now, how this pursuant to Janelle's comment, I'm not quite sure how 45 occurrences of idente crept in there, and this E also looks of uncertain provenance. There's also single studies capabilities that seem to have appeared out of here. Okay, so that's a good start. Suppose we wanted to sort those.
Sort by A.2.
Okay, sort. Okay. And what are we going to sort by?
A to A dot underscore 2.
Okay, so can we just say sort here?
Probably not a dictionary.
Okay, let's try this. Sort. We're going to do it based on. Okay, is this going to be a pair? What does it sort by? What are we sorting by here?
The number and the value.
Okay, so the problem is that each of these elements of this map is actually composed of 2 things here, right? It's composed of a key and a value, right? And if we want to sort by it, we need to sort either by the key or the value here. So we need some way of kind of processing them both. Okay. I don't think I asked you to sort it though, did I?
You did.
Did I? Okay. Okay. So how did you pursue this?
To a sequence.
Okay. So if we do to seek, for example,
Yeah.
now we have pairs. We have pairs. And having pairs, what could we do? Well, we could sort by them. Sort by.
I think it's sort with. Do they both work? Sort by and sort with?
Yeah, I think you could do sort by. And we'll do it. Okay, so actually we need to take in a pair of pairs, right?
Sort by only takes in 1 element. So
Oh, okay. So sort with, then maybe it is. Eh? Sort with, yeah. So that's going to take pairs. Sort by, let's try that. What is that? No, no, not 413. Okay, it's not cooperating with this. Okay, sort with. Let's do the sort with then. It's going to take a pair of pairs, and it's going to return a Boolean. So we're going to take, why a pair of pairs? It's comparing two things, and one is the the key value pair for one, and the key value pair for another. Okay, so we're going to have KV1 and KV2. Let's see if it can do this without further types. And we're going to compare if KV1's second part, in other words, its second element, its value, is greater than KV2's second part. Okay, here we are. Okay, so ladies and gentlemen, this toSequence rendered it into, just to go over that again, it rendered it to a set of pairs. This is the key, this is the value, this is the number of times, this is the word, this is the number of times that word occurs, and we then sorted with this criteria. Okay, and here we got out. That is the most common word, not too surprisingly, and of a
There are 117 specky.
There's also S's of
And 11 G's. 111
yeah. There's some data quality issues here. And specky is 117. Okay, so ladies and gentlemen, sorting. So grouping by words. How does this have to be changed if we want to instead group it by and count the number of times a word of a given length appears? What do we need to do differently here?
Instead of grouping by words in the initial group by, just group by their lengths.
Good. Here we go. So, something like that. The tyranny of small numbers. So, what is this telling us?
There's a lot of three-letter words.
There's a lot of three-letter words.
What's
Two-letter
weird
words.
What's weird though is in my results, they were in basically order until the 11th. It was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 11. So I'm wondering why this is different.
Yeah. Could be investigated. This is clearly showing that 3 is more common than 2, and I'd have to look into why that is. But what it's also showing is there are some outlying words that still occur even though they seem of implausible length. 36 length word, for example, does exist. But we do have some increase in here. We basically have 2 and 3 flipped, Connor, and then we have 4, 5, 6, 7, 8, 9, 10, 11.
No, you're grouping by, you're sort with groups by largest occurrences.
Right.
So the
That's
second
what
number
I
is the
meant.
occurrences,
Yeah.
so the largest occurrences will happen first. So I think it's sorted correctly.
Exactly. So this is decreasing number of
I
occurrences,
was talking about with the line was in
and
order from 1
and
to 10.
those map imprecisely to increasing length. So 3 and 2 here. You might think there's going to be more 2-letter words than 3-letter words, but that's not the case. Yeah.
But you'd think that given all the random single G's that the 1 would be higher.
Yeah. So what do we have for 1 here? 11 of them.
Somewhere below 600 or somewhere above 600 of them.
Okay.
1,000 some.
Yeah.
By the
It's 1,741 of them. Yeah. Yeah, you might. I agree with you. That's odd. Okay, so ladies and gentlemen, pipeline-based processing of this document, of this set of data, and an important point I wanna hammer in, because it's going to be challenged later this week as the preferred mode of processing, is that while we have a pipeline and we have a separation of concerns within this pipeline, successive criteria, successive stages of processing are separated out in a modular fashion into successive portions of the pipeline. We do have a situation where, as the pipeline executes, we're kind of mapping whole collections to whole collections to whole collections. And that is something that will be changing probably next time. Yes, Connor?
I'd like to see what happens if you remove everything up to the group by.
Okay.
I want to see what that data looks like.
Okay, I'm happy to do that. What would that mean? Let's use that as a little exercise here. Let me probe the length of this. Okay, so ladies and gentlemen, if we were to go back to this and eliminate things
No, that's not what I mean. I mean after the group by happens. I want to see what the last three things
Sure.
being done.
Sure. Yep.
So here's the problem.
I see. Yeah. Yeah.
You don't actually have the data you think you do.
Yeah. Exactly. Yes.
Changing the key.
So quite right. Yes. No. This is correct. So, or is that?
It's finding all the 5 lengths.
It's finding all the 5
It's
lengths.
finding the different occurrences of the 5-length words, not how many
Yes.
there are. It's saying that there are. n
Yes.
different
No. But I
lengths.
meant the occurrences. So
Well,
is
you
it
didn't mean
different?
the total
I meant the
occurrences.
total occurrences. Yes.
This is not the total occurrences.
You're saying what you had in mind was the different numbers of distinct words,
Yes.
not the number of occurrences. Yeah, and I was talking
see
about.
those as synonyms.
Yeah. So here, for example, where would it be? Doing might occur more than there and there, for example. That occurs 4 times in here.
Okay, so it did
Right.
work. This is exactly what I thought it was supposed to do.
Yes.
So then why are our values different?
I don't know, but we're probably not going to solve it right now. So this is 4 occurrences of there, for example. Here's a 5th, and each of those is being counted. So 5-length words. These are all the occurrences in them, including nasty. I'm not quite sure how that made it in the thesis, but okay. Okay. So here we have successive collections mapped 1 to 1 to 1. Good. Okay. So, ladies and gentlemen, we could push this further, but it's an interesting little example of processing of data according to these pipelines. Pipelines enjoy many virtues to recommend them. They're pretty easy to conceptualize what's going on. You can take a subpart of it and understand the job that it's doing. You can swap out pieces of it and swap in new pieces. We saw that earlier, right? All we had to do was to change, for example, whether we were grouping by the string itself or the string length, and the results would be different but capture certain commonalities. We can replace the later stage of the pipeline with another stage to sort with something else. So if we wanted to, for example, sort not by the number of occurrences here, but by the length. So if we wanted to see, in successive order, how successive lengths of words appeared, we would, this here is, okay, so we are sorting downwards, so let's do it upwards. So those are the words that were longer here. So here we are. So here, words of length 1, 2, 3, 4, etc. So we have a separation of concerns. We have form of abstraction here captured in the sense that we have these higher order abstractions to which we can say, we can pass rules, as it were. So, for example, sort by this criteria, where this criteria is in fact a function, right? We're specifying this function by which to sort. So these sort of pipelines are powerful. They form a very important part of today's programming environment for newer programming languages, whether it's Python, Ruby, Scala, or others. You will see these pipelines becoming increasingly well represented. And particularly when manipulating large volumes of data, these are very valuable, not least because they allow for, number one, parallel evaluation of a lot of these operations, and number two, memory frugal evaluation, as we'll see with streams. Okay, any questions on that take-home exercise before we move on to a discussion of a major topic that will last us through the end of the week?
I have
Yes.
a question. So,
Yes.
one of the key things we have been focusing here is
Yep.
separation of concerns and abstractions.
That's right.
But sometimes that can actually deter performance. For instance, you were talking about
Deter what?
performance, like
Performance.
decrease performance. For instance, you were talking about mapping and doing the lowercase separately.
Yep.
So that would mean it's a different for loop. But if you did it inside that map function where you are dealing with strings, it would have saved you a few more iterations. So there seems to be something of a trade-off here. So what's more important here, like the abstraction or the performance?
We're going to see how we can have both. And we're just as last week we took a look at the issue of functional abstraction and performance from a lower level perspective, and we saw that actually it's the occurrence of abstraction that allows us to perform profiling and understand where time is being taken within a program, in what functions, you know, there are bottlenecks exhibited, which allowed us to tune the performance. There, at a first glance, you might think, well, functional abstraction is getting in the way of performance, but from a larger picture, it's actually enhancing performance by allowing for accountability, where it's spending its time. In this case, you're highlighting something which is a substantive point for this case, and I welcome that comment, that by successively applying operations like maps, you know, if we had 3 maps in a row, one undertaking one separation of concern, you know, one type of concern, a second map yielding a different type of concern, a third yielding another, you might reasonably say, well, wait a minute, we could have done better by combining them, and it would have been perhaps less immediately readable, but it would have been higher performance because we wouldn't have done 3 sweeps over the data. What I would say to that is that much is true here. Whether it's map, filter, you could do a map and filter at the same time using something like Scala's collect operator, in fact. But as we'll see, once we get into the realm that we're about to enter now, which is the realm of discussing non-strictness and discussing stream-based processing, what you'll see is that because these pipelines can be implemented incrementally, what that allows to happen is that you can take what seem to be successive operations and combine them. And so what seemed to be requiring separate passes through the data, in fact, end up being compressed into a single pass, where that single pass can undertake multiple operations on each piece of data. And that's going to yield us both readability, performance, and memory frugality, the ability to perform the operations without the need to create entire whole collections at successive stages of this process, which together are a potent combination because they're easy to manipulate, to implement, to evolve, to divide up between many developers to test on the one hand. They are easier to parallelize because of the modular nature of it. At the same time, they can be high performance in terms of performing operations over millions of data items. And critically, when you're dealing with data like that, very large scale data, what is a key virtue is the ability to perform those operations without unnecessarily wasting data. So the ability to do it incrementally, to compress multiple operations into one, will be a key virtue. And we're going to see how that's enabled with the use of laziness, okay? Which is a major part of our next focus here on non-strictness and laziness as techniques to allow us to process data in these ways. So thank you for your question. Very prescient, substantial, and one we're going to be seeking to address. Okay? Other questions? Yes?
The Simon's SI's instructions say we should make our solution be able to execute in one line. So I thought you want us to write a .scala file, and we can execute .scala file in one line.
Oh.
Instead of doing this.
Oh, okay. So that's so to execute it in one line, like to call off to the Scala file?
Yeah, like Scala something .scala and take one prompt or something like that.
Oh, I see. Well, that's a creative solution to it. When I said one line, I meant something like this. I didn't want you to have to create a successive programming. I wanted you to get a feel for the pipelined mechanisms here. You know, I'll ask the interpretation be generous with respect to it, but I think you'll see some of the virtues of having this all on one line here. You know, in the context of an operation like this, it places the successive logic in a fashion that can be seen readily. Could you divide this up between multiple lines? Absolutely. It's just they wanted you to have the experience of doing it in a pipeline context. Okay? Yeah.
But programming it this way, it makes it that much harder to debug.
It can. It's useful for showing the operations. There's another consideration too, which is the ability to name the successive intermediate stages, which may be useful to illustrate their purpose. With the debugging, in a didactic context like this, often you can do a certain amount of debugging by basically examining what comes out of successive stages. If you were dealing with production code, you typically wouldn't string together this all in one place. You know, you would divide up into pieces which could be tested independently and so on. But this does provide a mechanism in terms of thinking through the operations that illustrates this idea of pipe and filter based programming. If you were to break this up into successive values, which are assigned sub-pieces of it, the same principles are going to hold, okay? So what we go into next with stream-based programming, the beauty of it is that's going to be able to be applied, whether this is written in 10 lines or divided up into 3 different methods or what have you, the same basic benefits are going to hold. It's much easier here to show it all at once in a class context if it's all in one line, okay? But that doesn't mean you have to write it this way in your code, and generally you wouldn't. This is a bit long for that, but the point is that having a clear mapping that conceptually comes down to a set of stages of processing that's modular does in fact ultimately enhance testability modularity for the sake of replacement, and in fact debuggability. And doing it all in one line is just a didactic trick. I mean, it's just something we do here. But you wouldn't do your major programming in the Scala shell, and you wouldn't put it all in one line. Okay? Okay. Other comments, questions? Okay?
Will you post this later because on this screen
Yep.
it's been cut off on each edge, so
Yeah.
when we want to
Yeah.
go back to watch the video, we cannot find the whole.
Sure. Yeah. I've been trying to post successive code fragments, solutions, etc. But I didn't post last Thursday, so I got to get around to it, and I'll try to post today's transcript as well.
Can you just maximize the window so it fits?
Console a little narrower.
Could I make the console narrower? Yes.
Maximize, just make it fit.
That's better. I think though there may be some, like what I actually see on mine includes a line or two, a column or two over here. I can actually see all of Scala, so I'm going to need to frob it. It's not just a matter of,
It's the projector cutting off.
it's the projector truncating it in a most unseemly fashion. So let's try this. Okay, I think that's a bit better. What do you think?
Yeah.
Okay. Good. Thanks for that feedback. I will try to remember that for future sessions, but would encourage you to poke me about it. Other questions, comments, requests, declarations? Okay. Great. So we will complete the recording.